Hello, physical science student. Welcome to lecture 5-3, covalent bonds. This is Mr. Worley. Before we start, let's make sure you have everything you need. You should have your book. You should have your book. You should have your book, a periodic table, and also I want you to have a piece of paper where you'll be taking notes and doing your end of chapter activity. Problems. Okay, so make sure you have all that, and make sure you also have a periodic table, at least know where it's at in your book so you can follow along when we need to go. Alright class, I'm glad you're here. Let's look at our objectives. We want to explain how unequal sharing of electrons occurs and how it affects molecules. We want to identify the properties of molecular compounds. This is different than ionic compounds, what we learned last chapter. We want to state what holds covalently bonded atoms together. Well, what holds them together? Last time, in ionic bonding, we learned that the positive and negative charges held them together. And finally, section vocabulary. Your exercises for this chapter are page 171, numbers 1 through 2, or the at-home activity. With your parent. Now, what that means is, if you read it, it says you need to demonstrate the action of soap to your family, and I want your parents or your guardian to write a one-paragraph description of what they learned and sign it. All right. So without further ado, let's go ahead and get busy on covalent bonds. My grandmother used to always say, let's get busy, before it turned into a funny word. Okay, check it out. Covalent bonds. Follow along. Uh-oh. You have a big project due in English class next week, and you need to write a story and illustrate it with colorful posters, art. Colorful posters and art. Sorry, art has never been your best subject, but writing takes more effort. Luckily, you're working with a partner who writes well but doesn't feel confident in art. If you each contribute your skills, together you can help produce a high-quality finished project. Next page. Uh-oh, wrong page. Okay, now we're moving on to page 167. Sorry, I'm a little slow this morning. All right. How covalent bonds form. Okay, just as you and your friend can work together by sharing your talents, atoms can become more stable by sharing electrons. The chemical bond formed when two atoms share electrons is called a covalent bond. Ooh, vocab word, should know that. Covalent bonds usually form between atoms of nonmetals. In contrast, ionic bonds usually form when a metal combines with a nonmetal. All right. In your notes, you should probably be taking down writing a little section about covalent bonds and how they form. I also want you to remember that ionic bonds usually form when a metal combines with a nonmetal, and covalent bonds usually form between atoms of nonmetals. All right. Electron sharing. Recall that the noble gases are not very reactive. In contrast, all other nonmetals, including hydrogen, can bond to other nonmetals by sharing electrons. Most nonmetals can even bond with another atom of the same element, as is the case with fluorine in figure 14. Okay, let's check out figure 14. Here's figure 14. We have two fluorine atoms. Each one has 1, 2, 3, 4, 5, 6, 7 valence electrons. Oh, Mr. Worley, how did we know that it had 7 valence electrons? If you check out your periodic table, you'll see that fluorine is in the 17th column, and from our last 2 chapters ago, you know that valence electrons follow the pattern 1, 2, skip the middle, 3, 4, 5, 6, 7. So 7 valence electrons. Okay. And so when they get together, they say, hey, let's get together right now and share 2 electrons. That's called a covalent bond. Nice. When you count the electrons on each atom, count the shared pair each time. By sharing electrons, each atom has a stable set of 8. See, 1, 2, 3, 4, 5, 6, 7, 8. Again, 1, 2, 3, 4, 5, 6, 7, 8. Because they each have a stable 8. Then the force that holds atoms together in a covalent bond is the attraction of each atom's nucleus for the shared pair of electrons. Ooh, yeah, that sounds like a good quiz question. What is the force that holds the atoms together? The two bonded fluorine atoms The two bonded fluorine atoms form a molecule. A molecule, vocab word, is a neutral group of atoms joined by covalent bonds. How many bonds? Look at the electron dot diagram in figure 15. Count the valence electrons around each atom. Alright, here's figure 15 right here. Alright, here's one valence electron around hydrogen. Here's 1, 2, 3, 4, 5, 6, 7 around, 1, 2, 3, 4, 5, 6 around oxygen. One more around here. Look, they share, and so now hydrogen has 1, 2, the other one hydrogen has 2, and this oxygen has 8. A water molecule has 2 covalent bonds. Ooh, 2, 1, 2. An ammonia molecule has 3 covalent bonds. 1, 2, 3. Sweet. So, hold on. That is my alarm going off. Oh, well, there we go. For example, where am I? I forgot. Count the valence electrons on each atom. Except for hydrogen, the number of covalent bonds that nonmetal atoms can form equals the number of electrons needed to make a total of 8. Hydrogen needs only 2 electrons. For example, oxygen has 6 valence electrons, so it can form 2 covalent bonds. In a water molecule, oxygen forms 1 covalent bond with each of the 2 hydrogen atoms. As a result, the oxygen atom has a stable set of 8 valence electrons. Each hydrogen atom can form 1 bond because it needs only a total of 2 electrons to be stable. Do you see why water's formula is H2O instead of H3O, H4O, or just HO? I hope in your mind there's a little bell going ding 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 ding. Yeah, I get it. I see that because oxygen only needs 2 electrons, it's only going to form with 2 hydrogens. It's not going to be H3O, it's not going to be H4O, it's not going to be HO, it's going to be H2O. Yeah. Science is so cool. Okay, let's go to the next page. Page 168, please. Now, let's study this chart right here. What do we see happening? And what do you see happening here? And what do you see happening here? All right, let's read and it'll tell us. Double bonds and triple bonds. Look at the diagram of oxygen molecule O2 in figure 16. Well, that's right here. O2 in figure 16. What do you see that's different? This time the two atoms share 2 pairs of electrons, forming a double bond. Ooh, looks like a vocab word. In a carbon dioxide molecule, CO2, carbon forms a double bond with each of the 2 oxygen atoms. Elements such as nitrogen and carbon can form triple bonds in which their atoms share 3 pairs of electrons. Checkpoint. What is the difference between a double bond and a triple bond? And I hope you say that a double bond is sharing 2 pairs of electrons and a triple bond is sharing 3 pairs of electrons. Yeah. Okay. All right, back in action. Molecular compounds. A molecular compound, vocab word, is a compound that is composed of molecules. The molecules of a molecular compound contain atoms that are covalently bonded. Molecular compounds have very different properties than ionic compounds. Compared to ionic compounds, molecular compounds generally have lower melting points and boiling points, and they do not conduct electricity when dissolved in water. Oh, yeah. Can you say quiz question? I can. Nice. Low melting points and boiling points. Study the table in the Analyzing Data box on the next page. It lists the melting points and boiling points for a few molecular compounds and ionic compounds. In molecular solids, forces hold the molecules close to one another, but the forces between molecules are much weaker than the forces between ions in an ionic solid. Compared with ionic solids, less heat must be added to a molecular solid to separate the molecules and change the solid to a liquid. That is why most familiar compounds that are liquids or gases at room temperatures are molecular compounds. Oh, I'm sorry. It looks like my screen wasn't quite right on the mark. Okay, get ready for section 2. This is the end of video chapter 1 for this.